Hello dear students. Today in this video I am going to discuss the last part of the chapter number 4, structure of the atom. In this video the two main topics I am going to take, that is electronic distribution in atoms as well as the valency of the atoms on the basis of electronic distribution in the atoms. So let's start with the electronic distribution, how it occurs in the atom. The following rules are followed for writing the number of electrons in different energy levels or shells. There are three rules we have. Let's discuss one by one. First one is the maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit's number or energy level index, 1 equal 1, 2, 3, etc. For example, for K shell, that is n equal to 1, first energy level. So the maximum number of electrons will be equal to maximum number of electrons is 2 into n is 1, so 1 square, which is equal to 2. 2 into 1 square is 2 only. And in the case of L shell, that is second energy level, KLM, that is the level we have learned, K, L, M, N, etc. This is the way. So the second shell is the L shell or orbit, both word we can use. That in the energy level index is n equal to second orbit. So the maximum number of electrons will be 2 into 2 square, which is equal to 2 square is 4 into 2 is 8. So in the second orbit or shell, the maximum number of electrons allowed, that is 8. And in case of M, that is a third shell. In case of M shell, the energy level index is, that is n equal to 3. So the maximum number of electrons can be filled in that shell, that is equal to 2 into 3 square, where energy level index or the orbit's number is 3. So 2 into 3 square. 3 square is 9. 9 into 2 is 18. Okay, similarly N shell. In case of N shell, n equal to 4. Clear, the energy level index is 4. So the maximum number of electrons can be filled, that is equal to 2 into 4 square. 4 square is 16. 16 into 2 is equal to 32. So this is the maximum number of electrons can be filled in their respective shells. Clear, 2, 8, 18 and 32. So this rule first we have to remember. Now the second rule is maximum number of electrons that can be accommodated in an outermost orbit is 8. Even though the first rule says about the maximum number of electrons can be accommodated in the particular shell according to the energy level index number or the orbit's number. But if that is an outermost orbit, irrespective of K, L, M, N, for example, if n becomes outermost, suppose, then even if it can be accommodated 32 electrons, but if it is outermost, then maximum 8. So irrespective of the type of shell or number of shell, if it is outermost orbit, the orbit if it is in the outer layer, then maximum number of electrons can be accommodated, that is 8. So this is called the octet rule. Octa means 8. So this rule is known as octet rule. Clear. So that is the second rule. And the third rule is electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. That is, first K shell should be filled. After that, L shell. After filling the L shell only, electrons will be accommodated in M shell, then N shell, and goes on. So these are the three rules we need to remember while we write in the electronic configuration of distribution in different shells of a particular atom. Clear, only these rules. First rule is maximum number of electrons can be accommodated in a particular shell. Second rule is maximum number of electrons in the outermost shell. And the third rule is the electrons should be distributed or accommodated in a stepwise manner. That means first K shell should be filled, then L shell, then M shell, then N shell, etc. It goes on. So these three rules we need to remember. So now we are going to discuss the electronic structure or the electronic distribution of the different kind of atoms with these rules. Okay. First, let's start with the hydrogen. In case of hydrogen, number of electron is 1. Number of electron is 1 as well as number of proton also 1. And there is no neutron. We are considering the normal hydrogen here, not the heavy isotopes like deuterium and tritium. So, 1 electron that can be filled in the first shell. 1 electron. There are something we need to remember, like in K shell maximum is 2. In K shell maximum 2. In L shell we discussed that is 8, and in M shell maximum is 18, and in the N shell maximum is 32, and goes on like that. This is the things we have discussed in the section of rules for writing the electronic distribution. Now let's discuss the second atom, helium. In case of helium, there are 2 electrons. So the 2 electrons also can be filled in the first shell, that is in the K shell. 1 electron and 2 electron. Okay. Now we are moving to the atom with 3 electrons. 1 in case of helium it is 2. Now we are moving to the atom with 3 electrons. That is lithium. In case of lithium, 3 electrons are there. So in case of lithium, 3 electrons. So first 2 electrons filled in K shell. Now one more electron is there that cannot be filled in the K shell, because in the K shell maximum number of electrons is allowed, that is 2. So we need to fill that third electron in the L shell, that is in the next shell. So the third electron can be filled in the accommodated in the third shell. And now we are moving to the next atom with its atomic number is 4, or number of electrons in the neutral beryllium. This is beryllium atom. It is 4. 4 electrons. First 2 electrons in the first orbit, no doubt. And third electron is already in the second orbit, according to lithium. Okay. Now one more electron has to be filled. So where will we fill? In the L shell itself. Because in L shell, that is second shell, maximum 8 electrons can be filled. So no problem. It can be filled here. It can be accommodated here. Okay. Now we are moving to the next atom, that is boron. In case of boron, atomic number is 5. That means in neutral boron atom, there are 5 electrons. One by one we are going, okay? 1, 2, 3, 4 like that. In the increasing order of the number of electrons. So first 2 electrons in the first shell, and the remaining 3 electrons can be filled in the second orbit, because maximum 8 electron is possible in the second orbit. Now we are moving to the next atom with a number of electrons 6, that is carbon. So in case of carbon, there are 6 electrons. So first 2 electrons here, and the remaining 4 electrons that can be filled in the second orbit. So total 6, 2 and 4. Okay. Now we are moving to the next atom, nitrogen. In nitrogen there are 7 electrons. In case of 7 electrons, first 2 electrons can be filled in the first orbit, that is K orbit, and the remaining 5 electrons, 7 means out of 7, 2 is filled in the first, the remaining 5 can be filled in, accommodated in this second shell or orbit, that is L shell. Okay, so 2 plus 5 is equal to 7, total 7 electrons. We are discussing in case of neutral atom, okay, not the ions. And next one is oxygen. In case of oxygen, there are 8 electrons. So here, see 2 first, and the remaining 6 electrons can be filled in this 3, 4, 5 and 6 in the second orbit. Now we are going to discuss the next atom with the fluor. At number of electrons is 9. In case of fluorine, 9 electrons. So 2 electrons already filled in the first orbit, remaining 7. 1, 2, 3 and 4, 5, 6, 7. 7 electrons filled in the second orbit. Next one is neon. In case of neon, there are 10 electrons total in the neutral neon atom. So first 2 electrons in the first orbit, remaining 8 electrons. 2 plus 8 is equal to 10. 1, 2, 3, 4, 5 and 6, 7, 8. Now this is 10. Okay, now we are taking the next atom with the number of electrons 11, that is sodium. In case of sodium, there are 11 electrons. Okay, in case of sodium, 11 electrons. So first we can fill the first 10 electrons like as we filled in the case of neon. 1, 2, 3, 4, 5, 6, 7, 8. Clear. So total 8 electrons we filled. 8 plus 2 is equal to 10. Now we know that in the L shell, the maximum number of electrons that is allowed is 8. So we cannot fill the 11th electron in the L shell. So we need to go for the third shell M. Clear? Because maximum number of electrons allowed in the second shell is 8 because of that reason. So we are going to the third shell in case of sodium. So the remaining 1 electron will be filled in the third shell, that is in the M shell. That is 2 in the first shell and 8 in the second shell. So 2 plus 8 equal to 10 and 10 plus 1 in the third shell, which is equal to 11. So total 11 electrons. Now in case of next Mg, magnesium. In case of magnesium, the number of electrons is 12. So same as this, first 2 electrons in the first orbit and the remaining 2, 3, 4, 5, 6, 7, 8 in the second orbit, and 2 plus 8 is equal to 10 electrons, and the remaining 2 electrons, there are total 12 electrons is there, that will be filled in the third orbit. Next we are going to discuss in the case of aluminium. In case of aluminium, there are total of 13 electrons. In case of aluminium, there are total of 13 electrons. So 2, then remaining 8, 1, 2, 3, 4, 5, 6, 7, 8. Then 3 more electrons are there that will be filled in the third orbit, because in the second orbit maximum is 8 electrons allowed. Now next one is silicon. In case of silicon, there are total of 14 electrons. There are total of 14 electrons. So first 2 electrons in the first orbit, then remaining 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 electrons. Then remaining 4 electrons, 2 plus 8 is equal to 10. Then total 4 electrons remaining now. Okay, so that remaining 4 electrons will be in the outermost orbit. This is the outermost orbit. Okay, the orbit which is present in the outer part. Next one is that after silicon, phosphorus. In case of phosphorus, there are total of 15 electrons. So first 2 electrons in the first orbit, then 1, 2, 3, 4, 5, 6, 7, 8. Then the remaining 5 electrons, because 2 plus 8 is equal to 10 only. Again 5 more is there, that will be filled in the third orbit. 4 and 5. Okay, filled. Next, in case of sulfur. In case of sulfur, there are total of 16 electrons. So first 2 electrons in the first K shell, then remaining 8 electrons in the L shell. 4, 5, 6, 7, 8. Okay. The remaining 6 electrons in the M shell, that is in the third shell. 3, 4, 5, 6. Next atom is chlorine. In case of chlorine, there are total of 17 electrons. So 1, 2, first 2 electrons in the first orbit, then 1, 2, 3, 4, 5, 6, 7 and 8 in the second orbit. Remaining 7 electrons in the third orbit. 1, 2, 3, 4, 5, 6, 7. So 7 electrons in the outermost orbit. And the last atom we are going to discuss, that is argon. In case of argon, there are total of 18 electrons. So 1, 2, in first 2 electron in the first orbit, the remaining 8 in the second. 2, 3, 4, 5, 6, 7, 8. And again 8 electrons. 2 plus 8 is equal to 10. Again 10 plus 8 is equal to 18. So 8 more electrons will be there in the outermost, that is in the third orbit. 1, 2, 3, 4, 5, 6, 7, 8. So now we discuss the atomic structure of the first 18 elements. Okay. Now if we go into discuss the atomic structure of next one, that is an atom with 19 electron, that is potassium. In case of potassium, symbol is K, okay? 19 electrons are there. So first we will fill the first 18 electrons as we filled in the case of argon. 2, 3, 4, 5, 6, 7, 8. Next again 8 electrons in the third shell. Four, 8. So total 18 electrons we filled. 4, 8. Okay. And in the second shell also 8. So 2 plus 8 is equal to 18. Now one more electron is left to become 19. So suppose if I am going to fill that 19th electron in this shell, because there are total of 18 electrons allowed in the third shell. So I am going to fill the 19th electron in the third shell. So total of 9 electrons will be there in the outermost shell. According to the first rule, I have filled this 19th electron in the third shell, that is, there are total of 18 electrons allowed. But according to the second rule, this is an outermost shell, so maximum of 8 electrons are possible. So then you may think that okay, then we can fill this electron in this fourth shell, because there are total of fourth shell we can fill, suppose. I am going to fill. Then again this is contradictory with the last rule, third rule. What is last rule? Said that unless one inner shell is completely filled, we are not, an electron is not allowed to accommodate in the next orbit. That means here, once this fourth orbit comes, the third orbit becomes inner orbit. So actually there are 18 electrons allowed, but we have filled only 8 electrons. So in case of an atom with the number of electrons is more than 18, there will be a small contradiction with this rule. That means some more criteria to be added to fill the electrons with an atom of consist of more than 18 electrons, which is this out of scope of our syllabus, so that we are not going to discuss. So by these 3 rules, remember we can only write the electronic configuration of the atoms with the atomic number or number of electrons 18. Don't try to draw the atomic structure of more than 18 electrons like calcium, like that. Okay, so that we will be learning the higher classes, because some more modifications, some more criteria will become, because we have studied only up to the Bohr atomic structure. Nowadays we are using one more sophisticated atom model, that is called the quantum mechanical atom model. So that we have not learned so far. So I am leaving that. Okay. Now I am going to discuss the electronic distribution in ions. Okay. First I am taking sodium. This is the atomic structure of a sodium neutral atom. It's not an ion. There are a total of 11 electrons. 11 electrons. Let's take in case of sodium ion. Now suppose this outermost electron is lost by the sodium. Okay. Then there are only 10 electrons in this. Okay, there are a total of 10 electrons. But as we know that in normal sodium atom, 11 electron as well as 11 proton also. 11 protons. So similarly here one electron is loose. Now remaining 10 electrons, but at the same time 11 proton is there because proton is not loose. So due to 11 proton plus 11 charge is there. Okay, there are 11 positive charges, relative charge I am taking, and due to this 10 electrons there are minus 10 relative charges. So while we taking the total charge, what will become minus 11 and plus 10, it will become plus 1. So if an atom is losing one electron from their orbit, it will acquire a positive charge. If it is lose 2 electrons, then plus 2 charge. So it is become ion. So we can write this as sodium plus. This is the sodium ion. Actually, this shell will not be here. Okay, once this is known, we need to write only 2 shell. So this is the electronic configuration of sodium ion. This is in case of cation, positive ion. Now let's take in case of chlorine. One more example. In case of chlorine, there are a total of 17 electrons. 17 electrons as well as 17 protons also. Because in neutral atom, equal number of protons and equal number of electrons exist. Now, if one electron is gained by the chlorine. So total how many electrons are there right now here? 2 in the first shell, and in the second shell 8, and in the outermost shell just count it 1, 2, 3, 4, 5, 6, 7, 8. Clear? So total of 18 electrons. But there is no change in the number of protons because proton is present inside the nucleus. So 17 protons only. So due to the 18 electrons, there are minus 18 charge. Okay, and due to the 17 protons, plus 17 is the charge contributed by the protons. So overall charge, the net charge will be minus 18 plus 17 will be minus 1. So this is the charge of this atom. So it is become a negative ion. So this is the structure of the chlorine minus ion. If an atom gain 1 electron, it acquire minus 1 charge. If an atom lose 1 electron, it acquire plus 1 charge. So this is the way how we can write the electronic configuration or distribution of these ions. Okay, if charge is given, then according to the charge, if it is minus, suppose an element is given like X, okay, any element 2 plus. Suppose in neutral X atom, suppose 10 electron is there. Suppose then in X 2 plus ion only 8 electrons will be there because 2 electron is loosened by this atom and it acquires 2 positive charge. So you have to consider while we writing. So this is very important while you go for it, calculating the number of electrons and drawing the electronic distribution of ions. Clear? That is very important both in case of cations, as this is anion and this is cation. So now we are moving to discuss the next topic and very important, that is valency. What is the valency? We have learned in chapter number 3, that is the combining power or capacity of an element is known as its valency. Clear? Now we are going to discuss this valency in detail in terms of the electronic distribution. Then valence shell. The outermost shell is known as valence shell. While we are drawing the structure of atom, the outermost shell, it can be K, L, M, N or any shell, depends on the atom. So that outermost shell is known as valence shell. And the next term we need to remember, that is valence electrons. The electrons present in the outermost shell of an atom are known as the valence electrons. The electrons present in the valence shell or in the outermost shell is known as valence electrons. These electrons will determine the valency of the atom or the combining capacity. And the next term we are going to remember, the elements with zero valence, that are called inert elements. And an inert element has completely filled valence shell and thus has no capacity to bond other atom. It has 8 electrons in their valence shell and thus it does not gain or lose or share the electrons. Example, helium, argon, etc. For example, I will show you the atomic structure of those atoms. In case of helium, In case of helium, this is the K shell. Maximum number of electrons is allowed, that is 2. Am I right? So that already filled. Now there is no space for gaining an electron by this atom. So that means it is acquire a stability. So there is no chance to get bond with another atom by this helium because it is outermost shell is completely filled. And in case of sodium, neon also. See, in case of neon, total 8 electrons in the outermost shell. According to Octet rule, maximum 8. So that is already filled. Now there is no chance for gaining an extra electron or making bond with another atom by sharing or losing the electron, because the neon will not lose also because it cannot gain, because maximum 8 electron is allowed, and it will not lose the electron also because already it is completely filled and it is acquire stability. So when the outermost shell consists of 8 electrons, not in case of helium, okay, in case of hydrogen and helium, that is in case of first shell, that is only maximum 2. I'm talking about the other shells. So in a case of other shells, if it is acquire already 8 electrons present, then that acquire the stability. Clear? So such types of elements. In case of neon also, see, there are 8 electrons in the outermost shell. Clear? So such types of elements are called inert elements, and these all are in the state of gases. So because of this are called inert gases. Now, if suppose an element consists of halfly or incompletely filled the outermost shell, like a 7 or 8 like that, such atoms has a particular valency depends upon the number of electrons present in that outermost shell. In case of an atom, if an atom does not have 8 electrons in their outermost shell, the atom would react to achieve an octet in the outermost shell. That means to get stability. 8 electrons becomes in the outermost shell means that atom becomes stable. So to get the stability, the atom will gain or lose the electron. And this was done by sharing, gaining or losing the electrons, depending upon the situation. The number of electrons gained, lost or shared so as to make an octet of electrons in the outermost shell give us the combining capacity of the element. That is, how many electrons gained or lost or shared to make the octet, to make the completely filled outermost shell. That number of electrons will give the valency of the atom. So let's discuss the valency of some elements in detail. I'm taking table 4.1 to explain the valency of some elements, which is already given in your textbook. In case of hydrogen, I'm taking atomic number is 1, number of proton is 1, number of electron is also 1, and there is no neutron in the normal hydrogen atom. That electron is filled in the K shell, in the first shell. So to complete this K shell into 2, 1 electron should be shared, or that means 1 plus 1 will become 2. 1 plus 1 will become is equal to 2. So that K shell will be filled. Either it is gain or lose, or it should be shared with the another atom. Clear? That how it is gaining, losing, sharing will be happen, that I will discuss after this step. So one more electron is needed to make complete. Clear? So that will become valence is 1. Only one atom can be shared 1 electron at a time with an atom. So its combining capacity will be 1. And in case of helium, I told you that there are 2 electrons. Number of atomic number, number of neutron, number of proton, I am not going to discuss. I am only taking this number of electrons, okay. So there are 2 electrons, that 2 electrons is already filled in the K shell. So there is no possibility to add or gain or lose the electron because it is already completely filled. So the valence is 0. Clear? It never combined with any other atom. Because there is no need of gaining or losing or sharing the electron to get stability. Already it is stabilized. And in case of lithium, there are 3 electrons. That 3 electron is distributed like 2 electron in the K shell, 1 electron in the L shell. So there is 2 possibility that L shell can be made into 8. So to make L shell into 8, 7 more electrons should be added. Am I right? 7 more electrons should be added. But if this 1 electron is loose, but if this 1 electron is lost from here, what will happen? The remaining 2 electrons in the K shell is already stabilized. My question is it easy to eliminate or remove 1 electron or add 7 electrons? Obviously, to remove one electron is easy than adding 7 more electrons to get 8 electrons in the L shell. Am I right? So its valency become 1. It will not go for adding 7 electrons to get the 8 electron in the second shell. Instead of that, it remove 1 electron so that in the first shell that is already stabilized. That is, it is already completely filled. Now, similarly in case of beryllium, there are 4 electrons that is filled as 2, 2. See here, to make L shell into 8, there are total of 6 electrons required. Then only it is become 8. But if this 2 electron is deleted, the L shell is already stabilized, completely filled. So losing these 2 electrons to get outermost shell completely filled is easy than adding 6 electron to get a second outermost shell is completely filled. Okay, losing 2 electron is easier than adding 6 electron. So its valency is 2. Similarly, in case of boron also, there are total 5 electrons, so it is filled like 2, 3. Here also, to make octet, 5 electrons required, 3 plus 5 in the L shell. So then only it's become 8. So here, if we remove these 3 electrons from here, the first shell is already completely filled. So removing 3 electrons is easier than adding 5 electrons, so its valency becomes 3. Clear? So it will combine with the 3 atoms. It will give 3 electrons to 3 elements, one by one. So its valency is 3. That means it is combined with the 3 atoms. It can combine with. Okay. And carbon. In case of carbon, there are a total of 6 electrons. It is 2, 4. Here see, either 4 electrons can be added to the second shell. Clear? Either 4 electrons can be added to second shell or 4 electrons can be removed from the second shell to make the first shell is completely filled. So the second shell will not be there. But here both are 4. So its valency is 4. It will not lose this 4 electron. It will share other 4 electrons. It will share the 4 electrons of other atoms so that there will be 8 electrons in the outermost shell. So its valency is 4. Similarly, in case of nitrogen. In case of nitrogen, that is different. In case of nitrogen, there are a total of 7 electrons, 2 and 5. So here 3 more electrons should be added to make 8. So what will happen? Is it easy to remove 5 electrons than adding 3 electrons? No. Adding 3 electrons is removing 5 electrons from this shell. So its valency become 3. Clear? Because either there is only 2 possibilities we have. Either we have to make the K shell be outermost or L shell is outermost with completely filled. So to make K shell completely filled, this 5 electrons should be eliminated. But it is easy to add 3 electrons to the second shell to make it to 8 octet. So its valency become 3. In case of oxygen also 8. So in case of oxygen 2 and 6 electron in the second shell. So only 2 electrons to be added to make it to 8. So its valency is 2. Because removing 6 electron is not easy one. And in case of fluorine, there are a total of 9 electrons. That is distributed like 2 and 7. So one more electron can be added to make it to 8. So its valency is 1. Similarly, in case of neon, total 10 electrons, 2 and 8. Already outermost shell is completely filled. So it will not react with any atom because there is no need of sharing or losing electron to get an octet in the outermost shell. So this is the way how it is. And in case of sodium, you can see Na. There are a total of 11 electrons, 2 and 8 plus 1 electron. That is in the third shell. In the M shell also, to make into stabilize 8 electron. Outermost shell should consist of 8 electrons. So to make 7 electrons should be added. But it's not easy to add 7 electron. It's better to eliminate this 1 electron so that the second shell that become outermost and it is already completely filled. So its valency is 1. That is removing 1 electron instead of adding 7 electrons. Similarly, in case of magnesium, there are a total of 12 electrons, 2, 8, 10, again 2 electrons. So it is easy to eliminate 2 electrons to get the second shell become outermost and it is already completely filled. Otherwise, we need to add 6 electrons. That is not easy. So it will go for losing 2 electrons to make octet in the outermost shell. So its valency is 2. Similarly, in case of aluminium, there are a total of 13 electrons, 2, 8 and 3. It is to get 8 in the outermost shell, that is 5 electrons should be added. So it is not easy to add 5 electrons. So it is better to remove these 3 electrons to get a octet in the second orbit. Clear? So its valency is 3. Similarly, in case of silicon, I already told you same as in case of carbon, because there are a total of 14 electrons, 2, 8, 4. Either 4 electrons can be added to the third shell, okay, or this 4 electron can be eliminated. So the second shell will become outermost and it is already 8. If it is adding 4 electrons to here, this also become 8. So either it can be adding or losing, but usually it possesses losing the electron because it is metal. So it's usually possesses the valency like a +4. Clear? Here there are some elements show the ionic valency like a charged valency, like losing or gaining the electron. But some atoms showing the sharing valency. So that I will discuss after this. Similarly, some more elements given in this table in your textbook. So just refer that one. And remember one thing. If the number of electrons present in the outermost shell of an atom is less than 4, then it will lose the electrons to make the previous orbit completely filled. Because it is already completely filled. After that only electron is distributed in the next shell. And if the number of electrons present in the outermost shell is more than 4, then it will gain the electron to make that particular orbit completely filled or octet. Completely filled means the completely filled meaning is that I'm talking about octet, okay, not the 18 electrons or 32 electrons. Become octet. So this is all about this valency. Okay, so I hope you got a clear idea, and just try to understand the valency of the other atoms given in this table. Okay, I'm not going to discuss that. The last topic I'm going to discuss, that is covalent and ionic molecules, how it is formed on the basis of the concept we have discussed. Covalent and ionic molecules. First one is covalent. In case of covalent, or compound or molecule, okay, that means it can be molecule formed with a different type of atoms or same type of atom. We already discussed in the second chapter. Formed by making a bond between atoms by sharing electrons. That is very important. Sharing electrons between 2 or more atoms. Let's take in case of hydrogen gas. Okay, that is example we have. So we have 2 hydrogen atom here with 1 electron each. In each hydrogen atom, 1 electron consists. Okay, I'm just represented by 2 different color, but electron are same. Okay, so just combine this. See how this shared the electrons. Now they came together and combine. Then they share the electrons. See, so in the orbit of first hydrogen atom, the left hydrogen atom, there are 2 electrons. Similarly, in the orbit of second hydrogen atom also 2 electrons. So that means their octet is not octet. The outermost shell, that is the first shell, K shell, is completely filled. Clear? So it is become stable. So this is the way how covalent bond is formed. That means by sharing the electrons to make the outermost shell is completely filled to acquire the stability. So now it is become stable. So this is known as H2, hydrogen molecule. Now let's discuss in case of ionic compounds. A compound formed by making a bond between the atoms by transferring the electrons. The loss of 1 electron from one atom and gain of that electron by another atom, resulting in 2 ions. The oppositely charged ions feel an attraction due to each other, that is electrostatic force. And this electrostatic attraction constitutes a bond between the atoms, which makes the formation of ionic compound. Let's discuss in case of sodium chloride, because we already said in the chapter 3 that is sodium chloride is an ionic compound. Okay, see here the left one is, that is, this is sodium, this is chlorine. Okay, so in this case of sodium there are total of 11 electrons and 1 electron in the outermost shell. In case of chlorine there are 7 electrons in the outermost shell. 1 more electron is needed to get the octet in the outermost shell. Here 1 electron should be loose so that the second shell become completely octet. Okay, that becomes outermost shell. So for that what will happen is that sodium lose 1 electron and it gained by the chlorine. See, this shell will be eliminated. So sodium, see here, the outermost shell of the sodium will be completely filled. That means 8 electron become octet. And here also, in case of chlorine, the third shell that is become octet, there are a total of 8 electrons now. So now they become stable. But at the same time, as sodium lost 1 electron and chlorine gain 1 electron, it acquire charges. Sodium acquire positive charge, so sodium become Na plus and chlorine become Cl minus because they become ions. One is lost electron, so it is because of that it has positive charge, and one is gained electron, because of that it has negative charge. As this become ions, that means charged species, there will be an electrostatic force of attraction, because we know that the charged species will be attracted by an electrostatic force of attraction. So that because of that, these atoms will be attracted by this electrostatic force and making a bond, and it forms as a single molecule. So this is the way how covalent and ionic compounds are formed. One is by sharing the electron to make completely filled. One is losing 1 electron by another atom. The same electron will be gained by the second atom, so that these two become ionic ions, and these ions will be attracted by the electrostatic force of attraction, that is, as these ions have charges. As it is attracted means they will stay together and form a compound or molecule. Clear? So this is all about ionic and covalent molecules. So with this video, I am going to conclude this chapter, and now I am going to wind up this video. So in the next video, I will come with another chapter. So that's all for today. Thanks for watching.